Hey guys, today we're going to look at lesson 1.4 in your textbook, and we're going to talk about transformations of absolute value in quadratic functions. So the first thing you need to know is what your parent functions are. The parent function is the most basic form of this function. So the parent function of the absolute value is f of x equals the absolute value of x. Okay? Absolute value graphs are always going to be V-shaped. That's something that you should know. And the parent function of a quadratic, f of x equals x squared, and a quadratic is going to have a graph that is always a U-shaped graph, and these are called parabolas. All right, so it's important to know what the parent functions are as we start looking at transformations, because transformations are just going to be the parent function moved and shifted, compressed, or whatever, to have a new function that looks the same, it's just in a new location on your graph. So a transformation function, you can use the formula f of x equals a times absolute value of b times x minus h plus k, where h and k is the vertex. Okay, very similar with quadratic, except you're using parentheses squared because it's a quadratic. And then h and k is still the vertex. So you can see that these are very similar, and what happens to them is very similar as well. So when we look at transformations, a, b, h, and k are just numbers, okay? And these numbers are going to tell us how this affects the parent graph, which we started with. So a, the number a, whatever number is in this equation for a, that's going to cause a vertical stretch or compression. B is going to cause a horizontal stretch or compression. H is a horizontal translation. And K is a vertical translation. So if you remember, vertical is going up and down. That's your that's your y-axis. And then horizontal, that's like left and right. That's your x-axis. So this is some useful information, general information that would be excellent to have in your notes so that you can reference back to it when needed. All right, you should pause the video and then look for the lesson in your book. This is the Learn the Math in lesson 1.4. So once you pause the video, find this, come back to it, and then we can work on it together. All right, transform absolute value in quadratic functions. Transforming absolute value in quadratic functions involves identifying the parameters of the transformation and comparing the parent function to the transformed function. You can compare graphs and tables to help. Compare graphs. Describe the transformations of the graph f of x equals absolute value of x. Remember, that's your parent function here, by comparing the parent function on the left to the transformation on the right. So this is your parent function. This is the absolute value parent function. Again, it's always going to be a V shape if it's absolute value. And then this is the transformed or transformation. Okay, that's the transformed function on the right. All right, you can see it's still a V. It's just been changed some. All right, so it says the parent function, the vertex is 0, 0. The left point is negative 2, 2. So negative 2, 2. And the right point is positive 2, up 2. So it's giving you 3 points on the parent function. So now it's asking what happens to the transformed function. So the vertex is shifted over and up. And it looks like maybe about 6 and 4, so this would be in the negative direction, so maybe negative 6, negative 4. And then the left point, it went from 2, 2, it went over, it looks like it's at maybe 7, and maybe 7 and 7, or negative 8, I guess it would be. Thinking it's going to be negative 8 and 8 would be my best guess here. kind of hard to look at on the graph here, but these are going by 2.5. So you can see that's -5, that's -10. So we're just kind of guessing at that left point there. All right, the right point, same thing. So we're going from the vertex. We're trying to locate this point, and it looks like there's a point about -482, I'm thinking. All right, so again, because that's -5, we're just kind of guesstimating there. If you go over and up, we know that's not quite to 10, so I'm guessing it's 8. So let's see. All right, so those are correct. And again, this one's a little challenging because they go by 5s, or at least by 2.5s, and you're kind of guessing at those points. At least it gives you a drop-down box that gives you assistance. All right. Find the values of h and k in the transformed function. The vertex of the transformed function is blank units to the left. All right, how many units to the left did we move? So we went from 0 and we went left 6 units because we went to -6. So we moved over 6 units. And blank units up. And how many units did we go up? So again, we went from 0 and we went up to 4. So we went 4 units up. All right, and this means that h is -6 and k is 4. So that confirms that what we're doing is correct. Then it says the difference in y values between the vertex and the right point is 2 minus 0. All right, so the y values, so you got 2 and then minus 0. So that is a difference of 2. The difference y values between the vertex and the right point and the vertex would be the 8 and the 4. So it says 8 minus 4, this answer would be 4, and we can check and make sure we got those correct. All right, so this is a lot of reading and just trying to interpret the information. Again, using the formulas I gave you hopefully will help. All right, this means the difference in y values for the transform function compared to the parent function is, and we did just say that's the difference in 4 and that would be the difference of 4 over 2, and 4 divided by 2 is simply 2. All right, it says complete the description of the transformation. The transformations of f of x to obtain g of x are a vertical stretch by factor of you can see right here it has a factor of 2. So g of x equals 2 times x plus 6 plus 4. That 2 is your factor. And a horizontal. So the inside the parentheses is the horizontal. So it's going to be a horizontal movement of 6 units to the left, and a vertical translation. If you go back to the original function, it goes plus 4. So you can see this right here, the plus 4, that's your vertical movement. And so this would be 4. All right, so those numbers are just coming straight from your original equation up there. All right, the diagram shows the path of a ball inside a racquetball court. Use the vertex, changes in the y value and x value, and the absolute value to help you find the solution. All right, so it looks like this side goes up 18, and it looks like this distance is 12, and this distance is 8. And we don't really know this distance, but let's look at what the questions say. The vertex is at, looks like the vertex is at 12, 0, because this would be the vertex. So our equation is g of x equals a times the absolute value of x minus 12. Use the point 0, 18. So we've got a point here, 0 and 18. We know that point. To help you find a when x equals 0. All right, so all we have to do is plug in another point. So we're going to plug in that x and y value. All right, so it says the equation is g of x, which is the same as y equals. Let me see if I can make this work here. All right, so y equals a times x minus absolute value of 12. And it says use the point 0, 18. So that's x is 0, 18 is y. So I'm going to plug in 18 equals a times absolute value. This time our x is going to be 0 minus 12. And that way we can solve for a. So we know the absolute value of 12 is just 12. So it's 12 times a equals 18 divided by 12. A equals 18 divided by 12 is 3/2. Or 1.5. All right, so that's how you would find a. Just substitute another point in and solve for that. So it says when x is 0, g of x, that's our y value, is 18. So a must be 18 over 12, which is what we just found right here, 18 over 12, which reduces to 3/2. This is the same value we obtained when we use absolute value and compare the changes in the y values. So they did the difference in y's here. So that's also going to be 3/2. And it says now our equation is g of x equals 3/2 times x minus 12. So all they did is substitute 3/2 in for a. Same equation here. All they did was replace the a with 3/2. So when x is 20, you can find g of 20, which is what is the y value basically. What's the y value when x is 20? So you substitute that in and you're going to get 12. All right. I think there's one more question. See if we can get it before the time runs out. Find the distance at which the ball hits the east wall. Okay, again, you can plug these in. Just plug these values in. If you plug in all the numbers that you had for your equation, you're going to see that when x is 20, y is 12, or g of x is 12. And again, you're going to use the equation above with the values given and substitute that in. So you've got g of x equals 3/2 times the absolute value of x minus 12. Go ahead and substitute in the 20, and you're going to see 20 minus 12. 20 minus 12 is 8. 3/2 of 8 is 12. So that's how you get that answer. All right, if you have any questions, let me know.